We can get started. So I know Angie didn't fully cover the domain adaptation work yesterday, so she will take over, but I need to leave to have dinner with Tom Kailat, so I wanted to kind of make sure I'm able to cover the rest of the things I wanted to talk about. So I guess tomorrow is the last lecture, right? So it'll be the recap of everything we've done. So I'll kind of keep the lecture flexible, so it'll be really depending on how people participate, what they want to really revisit or even extend further. So we'll keep that for tomorrow. So technically today is the last lecture, right? So we'll cover new things today. Tomorrow is more the recap of everything. And I guess the class presentation, the project presentations, we have to soon finalize, hopefully today or tomorrow. We have to, Ehsan, remind me, I think Shahin was also asking, we'll have to get our act together there. Sorry about that. But soon, hopefully, I think that'll be probably next week, given all the constraints we have for the coming week, right? I was hoping to make it like a workshop where everybody comes together, but given the time constraints, that may not be feasible, because that would have been fun as even like for intellectual exchange. But we'll make do with what best we can do given the constraints. So yeah, so today, let's kind of take a step up, right? Like let's zoom out and ask, with everything we are doing with machine learning and AI, what are the broader implications? And right now, I think it's the right time to ask that, because up until the last few years, many of them were still mostly in the theoretical realm or mostly toy-like settings, right? The impact it was having in the real world was more limited. Now there is potential for it to have a much bigger impact, so we have to ask these other questions too. And these are not easy, and many of them, it seems like, are not amenable to mathematical formulation, which we personally have a bias towards, right? We like to solve problems that are mathematically well-defined, things you can prove, have theorems about, prove certain guarantees, right? But that's not necessarily the case, right? We could try to still model some of these broader issues, but we have to be careful about that. And I think, so this talk will be more questions than answers, but I think this is something I encourage all of you to think, right? I mean, as being in this society, in this world, there are, issues of disparity, bias, discrimination. I think this is something we all need to be aware of to begin with, and then what are the ways to overcome that? There are no easy answers for this, right? And even without AI, these are hard questions. And now what is the place AI is going to have in either amplifying these biases, or can we have ways to minimize that or even try to correct for some of the biases, right? So these are hard problems, but let's kind of see where we are today with this. And, yeah, that's what these are all like, and I think Frederick Eberhardt is going to teach a course on AI ethics, probably in the spring, if I recall, or at least definitely over the next year. So that's where ideally I think there will be a lot deeper thinking into that, but I hope this serves as a warm-up. So, I mean, why is this important? As I said, we have a lot of biases and unfair treatment, unfair conditions in this world, right? So and that's like due to historical reasons. There are prejudices, there are stereotypes. I mean, this is the reality of the society today, right? So, I mean, we may have overcome quite a bit of it compared to the past, but there is still a long way to go. And so given that, what is AI gonna have a role in that, right? And you can see this kind of, it could become a vicious cycle if it's not carefully thought out, right? Because how you're collecting this data is dependent on our existing society with all its biases. And now if you're automating all the decision making to this AI models based on that data, right? In fact, it could amplify it, not reduce it, right? So technology is supposed to age the progress and help us go towards society that are much more equitable and much fairer. At least that's the promise of technology. But we have to be careful in how the technology is deployed, how it's used for that to truly happen. It's not going to happen on its own because of this vicious cycle. I mean, these algorithms are not going to be run in some isolation, right? It's a feedback loop, because based on the decision making, you're going to generate new data, and if you're only like doing it in this biased world, you can never come out of it unless explicit thought is given to that. And I guess that's the vicious cycle we want to avoid. And just scale and technological progress is not going to help, right? Just the fact that you're collecting a lot of data doesn't mean it's going to be fair. I mean, in fact, like I think when I talked about ImageNet, I talked about some of the bias issues, right? Like in the way how annotators are selecting it, but also much of the internet is centered on the Western civilization and centered on the privileged populations, right? So there's the question of representation of data from across the world. It's certainly not equal. And then even within that, how we are scraping that data and creating data sets demonstrates a lot of bias in the way these systems are trained. And then if you're trying to deploy it to wide populations, this can be hugely problematic. And so let me just kind of go through all of that together, right? So that can come in different stages, like where are the biases coming, right? They can come in every stage. I mean, as I said, first is the source is the data itself. I mean, you're collecting data of the current societal conditions that is certainly not fair in many ways, right? And then the assumptions you're making, I mean, you're kind of trying to assume certain things about the data. You assume it's fair even if it's not, right? That's one example of an assumption that you're making that is already creating the bias, and this is known as the anchoring bias. Like how you're anchoring your problem is already introducing bias. And then there are something known as framing effects, which means what are the objectives you're defining for your machine learning model. If you're only going after accuracy, that means it's ignoring all the other objectives, right? You're only going after revenue maximization, you're ignoring the other impacts. I mean, in fact, one example you can think of is this recommendation systems where it's only going with the click-through rate, and so if it's only maximizing the click-through rate, we all saw how that impacted our democracy, in the 2016 elections, right? It just keeps feeding people fake news and more fake news. They believe more fake news, right? It's this vicious cycle. And so this, and if only the click-through rate was optimized, right, it can never come out of this. So this framing effect can be really vicious because you cannot come out of it. And then it's this outcome bias, right? There are unexpected outcomes you don't even plan for. I mean, certainly at least when the hope is when Facebook had that algorithm, it didn't expect that it would end up destroying democracy. But these unexpected impact can happen because you're not, you're only looking at the level of one individual. If they're clicking these recommendations, it's ideally you're getting more and more clicks, and that can somehow lead to like better ad revenue maximization, right? But there's so many other unexpected effects because it's not just one human in isolation clicking something and leading to like clicking on ads, right? There are, the society as a whole, how is that impact quantified? And many times we don't think about that. So, I mean, these are all very complex multi-agent systems that are going to interact with the AI algorithms, and we don't even have good models that can do this. So these are some things we need to think about, right? As I said, I mean, no AI system is going to be an island by itself, right? It's going to have like implications in so many different levels. Like you can think about like now AI being used in law enforcement, right? Whether it's like for face recognition, right? Different kinds of surveillance, different kind of models to see when, who should be investigated investigated, who should be charged, and then in the legal and in the court setting, especially for like crime recidivism, it's even today it's statistical models are being used, right? Who is likely to recommit a crime? And that has all kinds of biases because the data on which it's being trained is highly biased. So how do we overcome this, right? And parole decisions, all this. So it's like in every step of our criminal and justice system, there's going to be implications of decision making, and now if that's being automated with AI, what are the implications, right? I mean, indeed, it's not saying currently systems are working well and AI is going to come and destroy that, right? Even currently humans are having biases when they're making decision making, but that's where the question of what oversight should there be to avoid that. But now if it's AI, how do we still ensure that we can have some oversights and we can have ways to ensure that it's not all just automated blindly? And indeed, it gets harder to look at the impact if you now look at multiple stakeholders at different scales, right? It's not just on a single individual, but like global ultimately, right? So you kind of are increasing this scale of impact, right? And there's also all these interaction effects. So, and that's extremely hard to do. People have done that before in economics, right? In multi-agent interacting systems. But what is the role AI systems can have in those analysis? And of course, in the real world, how do we quantify effects at different scales? That's still an open problem. And the other is the dynamics. I mean, this is not going to be static that you run this once and you're going to measure what the impact is. As I said, this kind of feedback system makes it extremely hard. And over the long term, how do even small disparities build up to big disparities, right? How do they kind of, this kind of runway feedback harms, like it keeps getting worse and worse and it builds up. How do we avoid that, right? That's a very tricky question, and we don't have great answers. So I'll give you some examples of where the current, I think, AI systems could have a big role in like looking at the current bias and possibly even amplifying it. So face recognition and face analysis in general has gotten a lot of recent attention. Many governments, including ours, are trying to automate a lot of surveillance through these systems, right? And now the question is, if these systems have a bias, first of all, where is that bias coming from and what implications do we have? So I'm borrowing quite a bit of material here from Joy Bolovini. Also, this is, I think, Timnit Gebru and a few others have been co-authors on this work. And so there's a website called Gender Shades where you can really look at a lot of details here. So if you go to many commercially available face recognition systems, Amazon, IBM, Microsoft, Clarify. So there are a number of ones. It's just publicly available. You can go, you can upload an image with a face, and then it'll try to say something about it. You can also, select different tasks. You could say that recognize a face, or you could have like a gender classifier. You could say what gender is this face. You could ask like all kinds of different, or does it have a mustache? Does it, what is the age of this face, and so on. Right, and if you see it's problematic, you take like Oprah Winfrey's picture, right? This was, I think, dated, so it's not. It may not give you the same answers today, but there was a high percentage, about 76%, that this is male, right? So, or like IBM Watson did the same with Serena Williams, or like Microsoft, there was Michelle Obama. So these are some examples of how these publicly available classifiers are wrong, but they're also wrong with pretty high confidence, right? So it's not 50-50. These are, like things, here this is like 90%. So, and that's something we have also addressed in the previous lectures of this epistemic uncertainty versus the aleatoric, right? These deep learning systems tend not to have good calibration. They tend to be overconfident. Even if they don't have enough samples of a certain kind, they'll still be overly confident, and you see that in action here. And this has a real world impact. It's not just an intellectual exercise. Face recognition is already being used in automated ways in a number of, our institutions. I think this was in South Wales, where, you can see that, a huge number of them were wrongly identifying. Right? Currently it's still like the machine is identifying and then a human is going and taking a closer look, so it's not, thankfully, completely automated. But you're already introducing a bias, right? If you are now saying this is a potential suspect, and if you don't it's already now making you go take a deeper look at this person, right? And their background, so the question of the ethics of doing that is very problematic. And in fact, in some cases, even the women were matched when the suspect was male, right? So there is a real world impact even when it's not making the final decision, right? So that's what we need to be careful about. And the gold standard is the problem, right? As I said, all our benchmark data sets are heavily skewed towards privileged populations, and the standard one, the open source, the biggest face data set is the CelebA, right? It's made of celebrities, and does it represent the average population even within the United States, right? Certainly not, right? There is so many demographics and attributes that are not covered if you just look at the celebrity data set. And the other is also the typical way that they present their face in these celebrity pictures, right? They're very good quality photo shoots, or they're heavily made up faces, especially for women. So that need not be the one you would have when you're trying to do this surveillance or other things. So there is an inherent bias in these data sets. The question is, how do we overcome that, and what is the impact currently with this bias? The problem comes when it's not only that it's biased, but if you look at the intersection, that's when it gets very problematic. So when we are talking about these fairness issue, I think intersectionality is the key, right? So it's so male versus female, these data sets tend to be heavily male in the number of samples, but also in terms of the skin shade. So if you now have the intersection of the both, so it's dark-skinned female, then that's when the percentages really drop, right? You have very few examples, and so with intersectionality, you see the performance drop drastically. Over all the publicly available face recognition, not just IBM, I just chose this example, so not to single out any one company, it's a problem across all the companies that, if you're looking at the minorities that are intersectional across multiple different features, right, then the performance can drop drastically. And machine learning is based on the average accuracy. It's averaged over all the samples. So if you only have very few samples in this intersection, right, it's natural that this will happen. So the question is, what are ways to overcome that? Right? And what you hope are at least national benchmarks. NIST tries to put up benchmarks for all these different standard tasks. At least you hope those that are certified to be a national benchmark to at least try to be balanced, right? So, and here you see it's still a very big problem. Even male versus female, there is a huge disparity in how many samples are just male. And now if you go to darker skinned women, it's just 4% of the samples. right? So, so this is, has a huge implication because what we think as a benchmark, national benchmark, is heavily problematic. And this is not just with images. Now, if you're trying to do text processing, most of these, right, training happens on things you've scraped off from the web. It's either like Google News or Reddit, which is a bigger problem. I'll come to that in a second, right? And they obviously have the biases that are present in our society. And so this work is, like looking at how, like you're training word embeddings. I think many of you have seen what word embeddings are, right? It tries to map each word to a vector, and by looking at simple vector relations, right, like addition and subtraction and these operations, you can try to see the nearness, which ones are near to one another. And so now if you like try to like ask man is to programmer, woman is to what, it will like kind of say the closest is homemaker, right? So it's like trying to like come up with all these biases and then trying to map the gender specific biases into the way we map these words. And so you can see here, the ones that are extremely correlated with she versus extremely correlated with he, right? There is a big disparity between the two. And it was also, you could also test this out with Google Translate. Like if you go from a gender sensitive language to a gender neutral language, and then you translate it back, right? So that's a blind spot because it's gender neutral, you don't know what the gender is. So that's where this biases of like how you had these word embeddings and how you had your training samples all shows up, right? So even if you like kind of switch the gender when you were going from English to Turkish, but now you go back to English, you will show these biases. And I think most recently, like Gmail decided not to autocomplete the gender. If you recall, there was, Gmail has this autocomplete, and that's because it was giving highly problematic suggestions. So it decided for now they won't like, suggest the pronouns. So pronouns is, because for now they don't know how to do this well, right? So this is, right now, if you blindly train this with your given data, right, this would naturally creep up. And the question is, how are you using this in decision making? If you are now automatically like processing resumes, right? So it's not just like structured text, like not just the fields that is just simple options, but actually free text, right? So somebody could say, now I have all these extracurricular activities of this is what I did, or these are other clubs I was part of, right? And it's just trained on existing data where, these are currently people who've been successful or kind of have been hired in the current organization. You're bringing in those biases, right? Even if you think you're not explicitly discriminating based on the gender, if you're now using these text processing and these free text is being mapped to certain vectors which are being used as features in your decision making, this is hugely problematic. And deep learning makes it worse because we kind of easily decouple these effects, right? We don't know how gender, kind of had an impact in mapping these vectors. And so in this paper, people these authors try to suggest some simple fixes. They said, try to look at like how with the gender, like, for both and female and male, like, try to debias and decorrelate, right? But that's only one protected feature. There could be many others. There could be race, there could be age. So what does it mean to be biased is still something we can't easily define. And how do we limit it is, mathematically this is challenging to do. But I'll come to that, in a minute of how we can mathematically define this.
Yeah, I'm struggling a little with what it actually means to say that it's biased, because if you could have a sentence that you would say so-and-so is going to do such and the such and such could be a verb or noun, and it's going to choose the right thing, and you say that's not a bias, statistically that's the way that works, but this is the same thing, but it's a bias because it's socially it's got social issues.
Yes, yes.
Right?
And that's the thing, right? Like bias is not just in isolation by itself, but in the way this algorithm is going to be used in the real world, right? So that's what will, get us to think about the bias,
And
right?
If it was a gender neutral, race neutral thing, you wouldn't care. You would want the bias,
Yeah.
as you're calling it, because statistically that's the way it is.
Right, and that's because the current data, right? So in fact, this model is working great on this given data set. The question is, how are you going to use this in the real world? Are you going to like make decisions on who to hire because you're processing resumes based on these word embeddings and not thinking about the impact it has, right? As an example, and so that's why it's problematic. Right, and many times, we are doing that. We have all these pre-trained models, embeddings, these Google Translate models. There are many pre-trained ones that have been trained on enormous scale data that many others cannot do. So people are blindly using those pre-trained models, right? It's already happening, and it's very hard to then decouple what kind of decisions it's making, and especially if you're taking those pre-trained models and building many other parts of the pipeline to make the final decision. Right, and in fact, the latest one was this OpenAI controversy on this new language model, and the Reddit. I don't know if you followed some of the things I've blogged about and talked about on this. Right, I mean, there are a number of other problematic issues, but also the fact that they used Reddit as a training setup. I mean, people have shown how it has led to so many biases in the model, and so. But then the question is, with all this, right? The main question is then how do we create good data for our machine learning? It's a chicken and egg problem because there's already so much of free data available on the web. I can easily then start doing my machine learning, start testing out all the methods, which is what a lot of the research community focuses on. It's much harder to say, can I create good data, or can I create good mechanisms for people to contribute good data, right? So we don't have that, and it's not an easy question, but I think more people should be at least thinking about that.
I think it seems to me that basically there are two separate issues. One is basically this domain adaptation type of issue that basically where we're collecting the data that might not be the appropriate one for whatever downstream task we have. But the other one is also that we're having a very subtle objective function in doing sort of wanting accuracy, but with these very sort of human societal constraint of not like being unfair to right? And these are a priori separate issues, right?
I mean, so I'll come to that in the mathematical formulation, because now you could conceivably think of solving a constrained optimization problem, right? You could say optimize the accuracy subject to some kind of impact parity or treatment parity constraints, right? And I'll come to these different formulations and see what are the pros and cons with that. So
they're separate from this domain adaptation thing in principle, right?
I mean, you could still have like bias data and still put those constraints, right? You could say, okay, I do have my...
Yeah, but I agree.
Right, so you could still do that, but but the data, I guess if you had good quality data, that would be a great place to start, right? That could make it much easier to solve some of the other downstream problems.
Yeah, I was just saying that even if we had like perfect quality data, sort of whatever, eliminating all these biases in the data collecting process, we would still not want to go for best estimation in general.
Yes, yes. I agree, because you could still add additional constraints on top.
Fairness constraints.
Yes.
We don't want some mean force in the background messing with any individual person's life, essentially.
And that's because we can't even generate data without the biases to begin with, right? If they are natural data, I mean, face recognition, that we can solve more easily because we can balance these samples, right? And collect samples in all different conditions. But text, how do you generate very balanced text? I don't know, maybe we could add feminist, publications in addition to the, the standard one, but it's still unclear, right? That's harder to do because, or especially historical hiring data or historical crime, that's problematic. How do you go and synthetically try to get a better balanced data? That's much harder. Right, so I mean the question, I mean this I won't address it, but something like a food for thought, does regulation kind of try to answer some of this? I mean, can you try to regulate these technologies, and is that the solution? Right, so again, the jury is out there. I don't have a stance on it because I'm still, debating this for myself, right? Should it be like through regulation, or do you hope the companies would in their own best interest also try to, create more fair systems because they worry about public opinions? So it's not clear, right? And in different fields have dealt with it differently. So if you look at like credit, like assessing the credit score and whether loans should be given to people, that's a historically regulated community, and people are using machine learning now, but it's extremely regulated. So if you talk to anybody from Capital One or Bank of America or these different banks or people, companies that provide loans and make these decisions, there's in fact a policy team, right? So every machine learning model is heavily scrutinized by this policy team, but that also means it's harder for things like deep learning to make an impact, right? So people still tend to do hand-engineered features, and it's very hard to change that. Let's say you now have a better algorithm that's actually able to maybe even improve the way you're giving out loans, right? It's harder. So regulation is two-edged sword.
So this policy team, for example, because it's a set group of people that will all have their own biases.
Yeah.
Is there a way to quantify the level of bias that's introduced by a policy team versus the algorithm itself?
So the policy team is more an oversight. They look at what the model is doing. There's also, and the government has a very specific set of regulations of what this model should and should not do, right? I mean, I don't have all the details, but those are there. So it's more like kind of at this point check mark.
So if the model reaches those standards, then it should be performing as good as any human that would be doing the same task, correct?
In theory, right? So again, maybe at least within that, the standard, on what data you're kind of checking this, right? So it's unclear because the way humans anyway, and that's a big issue with AI, right? When that makes errors, that then doesn't necessarily mirror the errors we make, right? So, and that's why it's even more problematic to kind of, and that goes back to even self-driving cars or other places where you want to automate using machine learning, because the way our system, our society is built is try to be robust to human errors as much as possible, right? So let's say there is a case of a road rage or a person really trying to kind of be suicidal, maybe then we have these crime prevention systems that try to identify and, as an example, right, try to mitigate that. But the way an AI system could cause accident is very different, right? It's if you look at some of the recent accidents, it's a Tesla car going up against this white trailer and thinking it's Sky, or this other Tesla car going head on to this concrete barrier, or this Uber accident where the LiDAR system detected the pedestrian, but then in that whole pipeline it somehow missed, right, because it was not calibrated rightly. It wasn't clear whether to, that decision of the sensor should be passed on downstream or not in the right way. So these are different ways the errors are made than a human would make. And that's problematic, right? We don't still have any known good defenses to these all these possible errors these systems can make. And I guess that's the big blind spot we have.
I think also regarding to this, shouldn't the AI system covers these as well? The humans, I think the difference is, for humans, if we have regulation, they also, their meaning goes beyond just the strict rules that they impose, but they also carry some normative weight.
Yeah.
Which sort of implicitly, when humans make decisions based on the rule, is sort of taken into account, but which I guess is missing
right.
with any set of rules.
Yeah. Yeah, so it's still very open, right? So the question is, can regulation help? I think it can help to some extent, right? In the sense, if there are secondary concerns, as I said, I think this is where the, the banks with their, loan decision making already have some of this, right? Is there explainability? Can you have transparency in the algorithmic process, so that the models now is going to this oversight team, it's being reviewed, it's trying to ask for different explanation. How was decision made in these, what was kind of a set of steps to decide to grant somebody a loan or not to grant. And this is where linear models are so popular there, right? Because then you can just go and look at the weights of different features. Whereas with the deep learning model, this is still very hard to do. And then the question of like privacy, like, if can you still keep this to be private, like if there's an impacted person, and then different errors, like how are these errors disparately impacting one community and not the others, right, or one demographic. So how that's distributed, right? And yeah, so all these questions of like where the data is missing, and importantly, like are there discretionary overrides? So, with currently in many of these systems, the human is still in the loop because, I think for still a long time, we still need the humans in the loop, right? They're definitely not at a place where it can be completely automated. I mean, certainly not self-driving, right? It's something we still need humans to be there, but it's, especially in these kind of self-driving systems, humans can't even immediately take over, even if you tell them, right? I think in that one example of the Tesla accident, the system asked the human to pay attention. I think it was 2 seconds before the crash or something, or 5 seconds. I mean, if it's that unrealistic at that point, it's hopeless, right? So it's much harder in those dynamic systems where it's the latency is the essence. Whereas if it's like this lone, like decision making, that's okay, right? You can take all the time to decide and like study and see if this really makes sense or not. But also even if you have time, you have to be careful. And people have shown this with like MRI and other radiology settings. If like especially if the person is trusting the machine, you tend to say, okay, let me just go with the machine, right? So you are still biasing the human to try to just go with the decision. So it's not always that every mistake will be picked out. So you should be careful there again, right? How you're kind of, and people have tried to say now, maybe incentivize them to pick out the mistakes, maybe reward them more if there are mistakes, or randomize, like not always show the correct decision, always, maybe also mix some of flip the decisions and show them. So there's all kinds of, interesting questions of how to then design this human intervention, right? And that kind of requires expertise of psychology, like what kind of cognitive bias and what kind of cognitive issues humans have when they look at making decisions, and especially if they trust this AI system or not. Based on that, how does that bias go into accepting the decision of an AI system? And based on that, how should you design a good interface? Right? These are very much open problems, and people really haven't addressed this because it requires these interdisciplinary inputs, right? And that's why these are hard problems. I think all these are highly interdisciplinary, and we are barely beginning to have these conversations across different fields. Okay, and yeah, so that's kind of like, if you think about how to combine, look at these different boxes within regulation and remediation, right? I think the algorithmic audit is something that machine learning people like us can really think about, right? Because it's like, this is very much in our domain to ask, what does it mean to audit an algorithm and audit a model? Right, like, what is like a data worksheet? I mean, we have all kinds of specifications. If you go to some electronics item, if you go to any, material, there's all kinds of specifications that's known, right? But when we collect data sets, in fact, and I've told this in the previous lectures, we throw away all that other metadata and other information. We keep very minimum amount possible in the way in which the data was collected. In fact, in many of these cases, we don't even have the raw annotations from the different annotators, right? So that's problematic. I mean, the first step is to have all that information and create, and also summarize it in good ways so that these worksheets are available. And look at impact assessments, like how does this impact different stakeholders, right? And these validations tests should be more open, like how we are deploying this in the real world. So currently, these companies do A/B testing, right? So like Facebook says, this is my current model, now I'm going to introduce a new model, I'm just going to like send it out, right? And and there could be so many other effects happening to kind of get to this point. I heard this in a coffee conversation, somebody who was at Facebook but no longer is at Facebook. He was saying that most of the A/B testing happens when Mark Zuckerberg posts something and then it doesn't go viral. Then people are trying to understand why it didn't happen, right? So then it's then they're trying out different models and saying when it should have gone viral and it didn't. So that's problematic if that truly happens. So again, this was don't take this at the face value, but this kind of shows the problematic, I think, black box nature of the way these tests are done. Right, so that's one. I think this is where we can also mathematically formulate what it means to audit, right? And some of these issues I have brought up in the earlier lectures, especially the data issues. If you can ask, now if you were to try to actively collect the data, how much samples would it require? That kind of shows how much diversity is there in the data, right? And also where, there are, and you can then look at the uncertainties. Where are these samples, are you very certain, but then it's differing from the ground truth. So this overconfidence issue you could try to detect based on already trained models, right? So many things we can do when we are debugging models, but we tend not to today. And that's okay for research if your goal is to kind of say, okay, I'm going to show one phenomenon and I can't take the entirety of it. But if it is going to go into the real world, this is absolutely needed. Right, and so we need to think about this. And the bigger ones of this regulation game, that's not, if you're a game theorist, you're an economist, I think this is kind of very much your bread and butter, right? What are the incentive mechanisms that I need to design? And based on that, how should the algorithm decision making go about? If you're recommending the same news item to everybody and it's polarizing the groups and it's kind of completely, leading to discord, then that's not a great incentive mechanism, right? So how do you bring in these questions of other objectives, right? And then what's a mechanism to maybe try for people to get to talk to one another, right? So these are all issues we need to, even in a toy-like model setting, people haven't done. Right, kind of combining mechanism design and AI algorithms. So think of an AI algorithm is trying to train a model that would be learned at multiple agents and then they also interact with one another, right? So we don't have even toy-like frameworks that address this, right? Forget in the real world how we can deal with it. So I think there's a lot of interesting questions. Mostly we are thinking of games within different machine learning systems, right? There's generator, discriminator, there's adversarial learning, but we are not thinking in terms of rational agents, human beings along with interacting with machine learning systems. That's very much still in the open. There's a bit of work, but there's still very much in the open, right? And then we can understand, again, there's also the game between the regulator and the actor, especially bad actors, right? And you see that with spam, you see that with all kinds of problematic bad behavior, right? So that game will always be there, but how do we try to understand that better? It's still open. Yeah, kind of to summarize, I guess we need to think about I guess the fluency means, are you capable of understanding and explaining what this AI algorithm is doing, right? That's the minimum. At least we should be able to do it, and now, especially with deep learning systems, we are far from doing it in many cases, right? Are you fluent enough to understand what's happening in these systems? And did you go through a procedure of transparency in the way you trained the model, what was the data you trained it on, what different objectives did you impose, right? What were the constraints, right? Kind of communicating that procedure transparently, I think, is important. And then, there should be an avenue for people to dissent. For instance, Joy has been writing to different companies and, really making this, she's being, very vocal about this, right? And some companies have responded better than others. I'll just, I'll let you go online and discover that for yourself, right? I think it's important for companies to be receptive to dissent and, address this in a way that can actually help us, right? There should be accountability for this, and I think these are some ways, right? I think this is the bare minimum, and we are far from it. In order to have a process that leads us to fairness, that leads us to ethical decision making. Right? Any questions, thoughts? So now we will go to some mathematical formulations. I encourage you to go to, there's a class, I think Moritz Hart at Berkeley taught, which is Fairness in Machine Learning. There's a large set of resources. We can also add the link in Piazza. So there's many mathematical formulations, right? And some are easier to solve than others, but that doesn't mean that's the right thing to do, right? And that kind of brings back to, I think we have to go back we can't decide this for ourselves, what's the best formulation. That's where we need the stakeholders. We need to, ask this to policymakers. We need to ask this for social scientists, right? Ethical research, ethicists, all these different people who've thought about it for a living, right? And so I think it would be too arrogant to think we can decide what's the best one. So the way I think about it is, okay, let's think of different possible formulations and mathematically what we can say about it, but it's not clear which is the one we should really be adopting. Right. And I think so I take this from Zach Lipton. There are many more, but I think these are the ones that are the most popular in terms of what does it mean to be fair. So think of the Z is the protected variable, so it could be the gender, race, or whatever you want your, whatever variable towards which you want to be fair, right? So you're incorporating all this in this variable Z, Y is the label. Right, so the popular way to think of parity or fairness is impact parity, right? So it's like no matter which gender you are, the probability you will get admitted to grad school should be the same, right? So that's a reasonable thing to ask, that your gender shouldn't determine whether you got admitted or not. Right, and so in this case, you're just saying the end impact is fair, right? But not the procedure itself is not necessarily fair. By that, what I mean is your procedure can still incorporate gender as a variable in the training and also testing process. But in the end, the outcome is fair, right? But or I could say, no, I also want to make the treatment to be fair. Right? So that means your classifier should not use Z in its decision making. And so that means it's blind. Like I'm going to be like gender blind. Like I will not even put the gender of the person during the testing phase. So when it's making the decision, I'm not giving it to the classifier. Oops, sorry. This is, okay, this is what happens when I get too excited. Okay. So whereas during training, I can still use the gender, right? So if I'm training it on resumes where gender is a variable, but now when I'm using the trained model on the test data, I'm gonna leave gender out. So now can I still, and so how do I do the best I can given that I no longer have gender? Right. And in many cases, like, in some cases this is actually done. So if you look at like auditions for some of the, I think the top, musical schools, or I forget which one, I think the LA Symphony does this. I think a few of these very top places now do gender blind and race blind. I mean, essentially you're just, hearing the music, you're not seeing the performer and you're making the decision. And in fact, I think there they got to gender parity very quickly once they started doing that, right? So in music, this was, this helped a lot in like achieving parity, but there you could say like, okay, it's what matters is only the musical quality, so I can judge this without knowing anything more about the person. On the other hand, if you have to hire this person in any other capacity, right, think in grad school or for a job, if their communication and the way they interact is also important, right? It can't be purely technical ability, right, in any of this, because we ultimately have to work together, collaborate together. So it's going to come into the decision making one way or the other, right? So in fact, it would be wrong not to have it in the decision making, because the success depends on those qualities as well, which we can't measure in the resume. And so it's not always feasible to be blind. And the question is, maybe being blind then hurts you, right? So that's what we want to ask. So is it possible so you could have just purely impact parity by itself, right? So you don't put any constraints on your classifier. Your classifier can use all the information available, but what you care about is only the end impact. Or you say that the model that I output will also not take explicitly into account this protected variable, right? And in fact, I think in the loans, decision making today, like for instance, I think race and other of these protected variables are not used, right? So there's a directive not to use that explicitly. And the question is, implicitly, you could still be using that, and what impact does this have? That's why it's very hard to judge that. Right, I mean the fact that there are areas with the higher incomes that have like more of the race disparity, right? So there is certainly like race is correlated with the income in many of the areas in the United States. So by incorporating the zip code, you're already introducing that, right? So there's surrogate ways in which you're introducing information about Z even if you're not directly seeing Z. Right? And that's where there are other now ways to try to minimize that, because one thing to say is now, okay, don't look at all these features X, your input X, but process it in such a way so that there is no way for you to infer Z. Somehow, you just don't have a way to infer what the gender or the race is based on this transformation. Of course, one challenge is by doing that, maybe you also destroy accuracy, right, by a huge way. And that's a big question of how do you do that. And the other is what's known as an opportunity parity. So it's like the false positive and the false negative rates match on the different groups, right? So in the way, like if somebody didn't get an opportunity, right, you should kind of be parity on that. So in the sense, it's not for P of Y for everything, right? It's more like only the sum of the conditionals you're controlling for. Like the probability that the person was not really passing the bar for hiring, but he got hired, right? Those kind of, you're only looking at some probabilities condition on the gender, not all the four. Like there's the box of all the four, right? Like the, let's say, binary hypothesis. So you're only looking at two of them rather than all of them. Okay, so these are different things, and this is easy to define, right? I can now, especially with like it's like a binary, let's say binary hypothesis, I can even write these problems down quite easily. I can put these additional constraints. I can ask, what is like the optimal classifier, right? Either in the frequentist sense or in a Bayesian sense. So I can write down these optimization problems, at least in simple settings. So one question that Zach and his collaborators addressed in a paper that recently appeared was, what is this difference between impact parity and treatment parity, right? Let's only look at these two parts. So the treatment parity is saying, now hide these protected variables, like hide the gender, hide the race, when you're using the classifier. So can you still achieve impact parity by having this additional constraint, or is it actually making things worse? What do you think the answer is? Yeah.
I was going to ask you a question. In practice, these steps are mainly a data pre-processing step, right? Not an actual algorithm step.
It could be, right? In this case, this is the actual outcome. We are now saying design a specific classifier that satisfies these constraints. Right, so we are now saying, let's now explicitly take fairness into account. Let's put these as additional constraints, and now let's see what happens. And there are different ways to put these constraints, right? These are the 4 classes. Okay, so, so treatment parity seems like at the outset to be very, the right thing to do, right? In fact, many people say like, I don't see color or I don't see gender, I'm blind, right? I think being blind is not the answer, will be will be what you'll see in the coming slides, that in fact that could hurt the impact parity by quite a bit, right? So why do you think this is the case? So treatment parity, all it's saying is don't explicitly use Z. Right, but X is correlated with Z. So the question of how do you kind of separate the two is very hard, right? In general, Z is not going to be independent of X, right? That almost will never happen. And so by like putting this additional constraint, you could be actually hurting in many ways.
Right, but so this is not meant in the sense that conditional on X being the same, Z should not matter?
Say that again?
And so the treatment parity just is not meant in the sense that conditional on X being the same, Z should not matter?
No, it's just saying use Z or Z however you want in your training. Just that when you're now doing classification, right, on your new testing samples, you should not use Z as the input. Your classifier does not have Z as the input.
I see. So but then in this list, is there anything that basically, because a popular idea is, right, you want conditional on some variable like how good someone is or something like that. You don't want some other variable to matter, right? That's a very common...
Yeah, so you still want this impact parity, right? So treatment parity puts an additional constraint. It says the classifier does not depend on Z, but will try to achieve like the parity as well.
Yeah, but then...
that's an additional thing you can put if you want.
Because impact parity is also not what it's saying, right?
Is what?
It's not controlling sort of for basically the way that the population might be. For example, let's say for grad school admission, there might be some countries that have highly developed university system themselves, so not many people from these countries will go to the US.
Yes.
Other countries have many people going to the US. And for example, these kind of effects are not, you would want to sort of control for something being equal and then Z not mattering, right?
So you're saying that's more like a data issue, right? There may just not be enough samples of like are you saying that or?
No, I'm saying that basically given whatever is like the population that enters your system, for example, people applying to grad school, so then conditioning on some variable, for example, where one is from, and then sort of this conditioning for many sort of things that I think would be what we consider fair measures, this conditioning still would give you a lot of information of how likely someone is good, because maybe from some countries you will have better applicants because there's more reason for good people from this country to come to us, just as an example. So that's what I mean, like, my understanding was that many times when things of these things one wants to condition on some like true variable that should be the decisive factor, and so condition on this being equal one wants some other variables to not have it.
But we don't know what that is, right? That's the problem. We don't know what we should be conditioning on. What's the really relevant feature, right? So if we knew that, as you said, everything is kind of correlated, right? Like even the protected variables and the relevant ones. And so, I'm not saying the impact parity addresses all the fairness issues, but this is one measure people use, right? Because it's simple enough to compute. I'm not saying this is the answer, but this is an option.
Oh, I see. So this is not purely not purely conceptual, but also just what things we can actually.
Yeah. Because you can, yes, the true thing is to say, yes, your gender or race, all these shouldn't matter. What truly matters is your capability, right? But what is capability? As you said, the way, these, of course, income, background, all these already are biasing how you're selecting people, how you're saying somebody is capable. So that's why it's so hard.
There's opportunity parity, right? Because it's opportunity parity, if you want to find like false positive or negative, you need to have some measure of what is the true.
No, but even here it's only based on like this kind of conditional, right? Like there is an underlying, yeah, so then it's more like kind of looking at, there's some ground truth, how close are you to the, but yeah, I mean, if the data itself is biased, it's an issue of like, how do you even get to that? Yeah, go ahead.
Can you explain again why adding some constraint could make the parity?
Yeah, I'll come to that. That's what the next few slides are. But any questions here? So indeed, there are a number of issues in even, saying if this is the thing we should be doing, but we can write down these mathematical problems, right? And especially it's not clear if you want to achieve just this incomparity only condition on Z, right? So there could be other things you truly want to condition on, which should be the relevant features to make the decision, right? But that's hard to say what are those relevant features. So let's kind of go with these definitions. We'll focus on these first two, right? And as I said, the second one of this treatment parity, we can ask what impact does it have? So if now you're putting a constraint that don't look at Z during your testing, your classifier should not depend on Z, what happens? I mean, as I said, these are issues we already talked about. None of these completely address, right? So that's what this, and it's called this disparate learning process, which achieves this treatment parity. So meaning these are called sensitive or protected features, right? So this Z is not used in your model during testing. You can still use it during training, but you're not allowed to use it in testing, right? And so we also call it blind classifiers because the classifier is now blind during testing to these sensitive features. And how you do this, I mean, once you write down this optimization problem, there are many ways, right? I mean, the optimization-based ones are natural things to start with. You can say, now there are additional constraints to my problem. I mean, if you're looking at like base decision boundary, I can now add these additional constraints. For simple like hypothesis testing, right, you can immediately write down what the, and kind of what how the classifier changes, right? So for simple problems, you can write this down, and maybe that's also the bias why we tend to kind of write about these constraints, because these are something we can mathematically solve, right? But you can also then ask, maybe I should also think of representations. Maybe, if you remember, the other part was this representation parity, right? Can I learn these representations where I remove all this information about Z? You could then do like GAN-based or other based representational works to try to learn this transformation and trying to make it indistinguishable with the protected feature. So mathematically, this is not the most challenging thing to do, right? I mean, once you write this down, it's pretty intuitive how you can go about it. But the question is, what is the end result? Are we truly achieving better, equity with these solutions, right? I think that's where it's much harder to understand. So this is a toy example from the paper. Don't worry about the exact numbers here or this exact process, right? So this is a toy example where the Y is this final outcome is whether somebody is hired or not. And let's say this ground truth of how they are hired or not only depends on the length of work experience. So in this toy example, all that matters is how long somebody has worked, right? Should determine whether they're hired or not, right? So that's all that. This is the generative process. Assume in this toy example, this is how the actual labels are generated. And now I'm going to introduce a variable that's completely irrelevant, right? So let's say the hair length, I mean, how long somebody's hair is, right? And based on if the person is male or female, they're going to, the distribution will change. I mean, and so that's a variable that's completely irrelevant to the ground truth, right? In really who should be hired or not, right? I mean, ideally you don't want your decision making to depend on that. But now if you're trying to have impact parity, which means the probability of Y should be the same condition on Z being the male or the female, right? So we want to have this impact parity. You can't have it if on average, let's say there are more men with more work experience, right? So I mean, historically, like, our society has favored men to have like longer work experiences, and now you're kind of creating this vicious cycle that they are getting hired more, and so you want to like try to correct for that parity. I mean, let's say that's what we want to do, right? I mean, again, it's an open debate if that's what we want to do, but let's say that's the goal, is to have impact parity, even though there is a disparity in terms of the overall distribution of the work experience, right? So if you're trying to do this, right, what happens is, because you want to make this impact parity, right, you're trying to say, this probability of y given z should be the same for both the classes, right? So you're not just making your decision based purely on the work experience. Right, so during training, you're trying to correct for the gender impact, and so even though this variable hair length was not relevant in the ground truth generation, it now becomes relevant, right? It becomes dependent, because the hair length is going to give you information about the gender of the person. Right, so if on average women had longer hair length, by looking at hair length, you're now inferring that somebody is a woman, and now using that inference to make it more fair in terms of the impact parity, right, to achieve better impact parity. And that's why this is now all problematic, right? Even though a variable that was completely irrelevant ends up being relevant when you put the constraint of treatment parity. Right, because you're not explicitly allowed to use the gender in your final classifier. Now you're trying to use surrogates for the gender to achieve this impact parity, given the constraint that you cannot directly use gender. Is that clear? And so what does this end up happening? So in this case, right, so this like top triangle and this bottom triangle means who was advantaged by this, the disparate learning process. So that's when you're only, you're using this constraint that you're not using gender as the variable in your classifier during testing, right? So who is advantaged and who is disadvantaged? And if you plot it according to the hair length, you see the women who otherwise would not have gotten the job but got the job were all having longer hair lengths, right? And actually the women who lost out had more work experience but shorter hair length, right? Which is really kind of, which is actually really terrible, right? I mean, these are the most capable women, and now you're like hurting them, right? So it's like violating this rule that it's not harming anybody, right? In fact, it's harming the women, right, whom you're actually trying to help here. And so that's why we should be very careful. I mean, this is indeed a very toy-like example, but intuitively you can see this can happen everywhere, right? So, if you're trying to say that, I want to try to correct, make it more fair, like I want to achieve impact parity, but now I'm not going to directly allow you to use the gender of the person to do that. So the model will somehow implicitly try to infer the gender of the person. And so where that inference is bad, so where, somebody who is stereotypically male but looks like a male in this feature, right, in this feature space, but is actually female, they will be disadvantaged by this.
But it helped the hippie.
These are the two men it actually helped. They were also with shorter work experience, right? So that's the thing, like it's actually helping people who, honestly, you'd rather be helping these women here, right? So you'd rather be wanting to achieve that. Rather these ones here, right? So these are the ones you really want to be helping. And so in fact, you're hurting the most capable women in this example. Right? This is indeed toy-like. I'm not saying that's what happens in all of our society, but that's, it gives you a window to how, things you're also, when you're trying to make things fair, it's still very unclear if that's the end goal that's being achieved. Is this clear?
So in this case, originally we only decide on one parameter, which is work experience, right?
Mm-hmm.
And now we introduce another variable, which
Mm-hmm.
is y hair length. Then we try to make it fair, but actually mess it up.
Yes, because even though it was completely irrelevant, right? What the treatment parity is constraining you is saying don't use the gender, but still try to have gender parity in your impact. And when you're putting that constraint, then the algorithm is implicitly trying to infer gender, right? And hair length is a very good indicator of gender because on average, more women have longer hair. But then, like that's the problem, right? Fairness is no longer about averages. You're going to still hurt some women. Maybe it's less number of women, but still you're going to hurt some women who have shorter hair in this toy example. And so the idea is now you're thinking of parity again in some like monolithic way, right? Let's make male versus female, but there are also lots of subgroups within that. And so you could be disadvantaging subgroups within this protected feature, right? That is problematic.
Sorry, I'm still kind of confused. This is basically a combination of like, trying to achieve whatever the first parity was called, while at the same time having treatment parity.
Impact parity.
Impact parity, while at the same time having treatment parity.
Yeah.
That was, because I had first thought that basically, for example, people might think that something like treatment parity is one way to achieve some notion of fairness by itself, because you're not explicitly using these variables anymore. So
sorry. So,
why you use the two of them together somehow?
No, I think in this, we can go back to this. I think here, so you can try to use both, or even you could try to use only one, right? So here, actually this unconstrained one had this P% rule is like the impact parity, right? Like how close you are to impact parity. And so people, what's the point of doing this otherwise, right? If you're only saying, I'm going to try to achieve treatment parity, but the historical data is not going to be fair, right? So just saying I'm going to be gender blind doesn't solve the problem, right? So that's why you have to, people try to do both together, otherwise, in the end, there's no impact of having a fair system. Treatment parity by itself will not solve the fairness issue, right? It's just saying, don't include gender in your classifier, but it's not clear, right? That by itself does not make it fair.
Yeah, that reasoning I understand, but I'm just surprised because I can't imagine a situation where people in practice would come up with the idea of using both wanting to optimize for impact parity, but while doing this, tying one hand on their back by saying we also want treatment parity.
By the way, tying, and this could be due to regulation actually, right? So this treatment parity could be in the loan kind of process, right? If the government says don't use the race, then you can't use it. Or somebody in grad admission office says I'll remove gender and hand over the applications to. This could be something else that's constrained upon the system, right? Of course, that's what this is saying, right? If you don't want this constraint, this is a bad constraint. But in many systems, this already exists, or many people may think this is a good way to do it, right? So it's not. It's overtly constraining the system and could lead to bad outcomes in other ways.
I see. So because basically here you're assuming that really what the user are doing, they're actually having something better in mind than what this system around them is.
What do you mean?
You're assuming that the user is actually aiming for impact parity.
Yes.
Assuming you impose these constraints because you're not hoping that you can rely on the user trying to aim for it.
You're hoping that once you have treatment parity, right, it will also lead to better impact parity, right? So that's what you're hoping, right? That's kind of even when people say I don't see color or I don't see gender, in the way I think, they hope they're treating the person fairly, right? But that's not necessarily true. And it's certainly not true for machine learning systems, right? Just because you impose that the parity should be fair doesn't mean the impact will end up being fair.
Yes. Yeah, but that is a separate issue from the one that was just presented, because the one you just presented also made this assumption that the classifier is trying to aim for impact parity at the same time. Right?
And you can put that constraint at different levels, right? How much impact parity you want, but there's, the effect will still be there, right? So there are, in the paper, there's a lot of different, you can say I want impact parity up to this percentage, right? Like this much violation I can allow. So you can do it at different levels, right? But that's not the more kind of thing is, even at different levels, you would still have, it depends what that level is, how that would disadvantage certain women, right? So, but it would still, that phenomenon would still be there. I mean, because if you think of like regulatory laws, right, you try to, ensure both, impact parity makes sense, but in many cases by law, it's also treatment parity, right? You're just not given that information. You're not allowed to even collect that information in many cases. And this is saying that actually is bad, that could hurt impact parity, which is intuitive. Right? Because for a lay person that may seem really fair. Yes, I'm not even collecting this information, so this will lead to a fair system. It won't, right? So that's what this is showing. Right, so, and the same was true, they collected a data set of grad admissions. Thankfully with that data set, there was no bias they could find, right, so, which is a good thing. But then they synthetically added a discrimination to kind of say if there was historic discrimination, right, this is more I guess, fairly modern data sets, so at least they couldn't detect a bias, which is a good thing. But then they wanted to add the synthetic bias and say, suppose this data was biased to begin with, and now I impose these parity constraints, right? Will that lead to a fairer system? And they found the same phenomenon, that if they added this treatment parity, right, there were still many women who were rejected by it, right? So it's gonna, there's certainly women who are impacted negatively by this treatment parity constraint, even if you think you're helping women. Right, so that's kind of the takeaway from this, that now if we are forcing this, if we are withholding information from the classifier, it will try to infer it in very non-obvious ways. And so women that don't fit the stereotype, or any other protected feature that doesn't fit the stereotype or the typical example of that protected feature, right, will be the ones that will be disadvantaged. Right, so that's why, the goal is not to prevent that information being collected, but to maybe ask how you can still use that in achieving better parity. That's the takeaway. Any questions here? And I think the statistical notions are clear here, right? Even though a variable is not relevant, once you have the constraint, it becomes relevant, right? So the constraint is kind of creating that dependence, and it can then affect in so many other ways. And that's why this is so hard, right? We are trying, even if we have the noblest of goals, how to achieve that in a real society is going to be really hard. But yeah, that's kind of, you can, to conclude here, it's saying you want to have treatment disparity, right? You should treat the different groups differently, right? Meaning the classifier should take that input and give different decisions based on that, even the sensitive features. That's the best thing to do to achieve impact for parity. Because if you don't do that, if you limit the ability for the classifier to use this protected feature, then there are two different scenarios, right? In one is when this input X completely encodes Z. So that means you can perfectly infer the gender given some other input, right? In that case, it's not very interesting, because even if you're protecting it, you're removing it from your classifier, it's still inferring it completely. But in most cases, you can't completely encode Z, right? You can't always tell what the gender is once you've removed that. But then when you're making these errors, that can propagate in very non-obvious ways. So meaning some person who doesn't look like a female based on these features will be disadvantaged, right? So that's important to think about. And there's so many other things that are not addressed at all, right? We talked about the dynamics. That's an issue which requires a lot more thinking. I think maybe the question is whether causal inference can be an answer to some of this, right? If you could truly understand what are the cause and effects, then we could intervene. We can make like kind of the right decisions of what the fairness is, but we don't know, right? I mean, there are more correlations than causations, and that's a whole other topic, right? I mean, you can go talk to Frederick Eberhardt about causal inference, but if we could do this, then a lot of these problems could be solved in better ways.
So basically, everything you said here applies to when the human is the AI in systems that don't involve computers at all. And in fact, computer-based systems could ameliorate the problem that we have societally.
I think the jury is still out there on the last conclusion, right? I mean, the hope is it can certainly do that if we can build the right mechanisms in which they're used, right?
We can make it more objective.
Yeah.
And humans aren't going to be objective.
But the question is, I mean, in the end, they will still interact with humans in many of these cases, right? So the question is, first of all, what does objectivity mean, right? If the data cannot be objective at all to begin with, then how do we address it? That's where the challenge is. The way we think that technology can be objective is not going to be true with many of the AI systems.
I guess the point I'm making is that we struggle with exactly the same problems
Yes.
without talking about AI.
Yes, I agree. And in fact, that's why this kind of notions of parity have, they date back to the 50s or 60s, right, with all the laws of like discrimination and like issues that we dealt with back then. So many of them can be dated back to that. But I guess what's modern is the scale at which we are collecting data and the even more like kind of lack of transparency that these deep learning models have, right? I think that's what makes it much harder to even reconcile these notions.
Although humans aren't terribly transparent either.
Yes. Yeah. I mean, the question of whether AI is going to be better or the human is going to be better, right? I know.
Yeah.
That's,
I'm not advocating necessarily for one or the other.
Yes.
But it's a potential something that could be done, that could be positive as opposed to negative.
Yeah. No, I certainly hope that's the case, right? But it's not going to come from just taking the data we have based on human decision making and feeding it. In fact, that could amplify the bias, right? Because it could try to say, like, I'm getting a lot of reward for hiring these people, let me hire them more and more. And now I'm like launching it in all the companies, so it's kind of further amplifying this, right? So it's could like kind of, if you don't have enough diversity in the models we train, it could just make all these decisions go towards one, like the big gets bigger phenomenon, right? And that's dangerous. And that's where, thankfully, I don't think that's going to happen. There's always, humans are still involved in how these models are deployed, but we have this opportunity to make these decisions in an informed way and think about this, right? I think many of us, think that this is not our domain, we shouldn't be thinking about it, right? We design the machine learning algorithm and let somebody else bother about it. I personally don't think that's the solution. Okay, so, and I mean, there's also the broader question, right? Yes, for just the purpose of like, us being like, okay, we should be fair and ethical, we could go about solving these problems. But also it may just improve, machine learning by itself, right? Because, as I said, like if we are not having good quality data that's leading to these biases, that means it's not a good machine learning model, right? It can never reach human level performance, or it's a self-driving car that's getting confused by a white truck. I mean, this is hugely problematic, right? So by trying to ask what are the biases and how to make it fair, we could, it's also related to better machine learning. And so that kind of goes back to saying, I shouldn't just look at the average accuracy over all the classes or all the instances, right? This long tail, the world is a very long tail. How do I measure this performance better on this long tail? In fact, it's a never-ending tail, right? And that's hard. And this relates to domain adaptation, which Angie talked about. I'm not sure we'll have more time today to talk, but I encourage you to think more about, right? I mean, this very much relates to domain adaptation because in many cases, the training data is not the distribution you would like to be testing on, right? So there are, and the other is not just looking at averages, which machine learning tends to do. If that every sample is a human being, right, we also need to worry about what happens at the instance level, which machine learning problems don't tend to think about, right? And at the core of all this is what is interpretable, right? And we've talked about it in some of the previous lectures. We said robust learning could lead to interpretability, right? Or this other thing could lead to interpretability. So the question is, imposing the fairness constraint could make them more interpretable. To me, it's not obvious just by itself. It's not going. It's more like a band-aid, right? By itself, it's not going to be interpretable. Whereas interpretable models could lead to more fairness. I think that direction is very clear, the other one is not. But yeah, I think these are things we still need to think about. I especially encourage all of you to think about better data, right? Like, I think this kind of leaderboard chasing culture of, okay, this is now the Olympics of our times, it's not, right? So that's not how the incentive should be aligned, right? Like, try to think about research problems where, can you ask, why just go after these benchmark data sets, or find problems with those benchmarks, right? Like, so just because there's a big already set of papers that are using that doesn't mean it's the right thing to do, right? Question those, I think question all those assumptions that are made. I think we can lead, and it could result in much better research through that. Great, so I think we have a few minutes, so any closing thoughts or comments before we end?
I think I just quote that machine and AI, they're not biased. We are biased. So it's like, it is how we use machine learning, how we use AI, how we collect data, and how people, it's all go back to us. So.
Yes, I mean, machine learning, it doesn't have consciousness right now, right? So, when we say machine learning, it really means us, right? We are the ones designing the algorithms. We are the ones saying what data to be collected. So, yeah, so, yes, it doesn't mean we blame everything on machine learning. Yeah. Great, thank you.